Key issues in energy today, rising energy prices, security of supply, and climate change, imperative that the energy efficiency industry plays a large part in the future actions in reaching the UK goals going forward. I think the key word in the title of my presentation here is reliable, in that any new innovative technology that you want to implement needs to be reliable. You need to have some confidence it's going to actually work. Too many new technologies are founded at the first hurdle. So I think it's important that confidence in how a new technology can be actually implemented is developed. So we might talk about that a bit more as we go on. Firstly, though, just briefly introduce who we are. As Dalkia, we're part of the Veolia Environment Group, which is an international group providing creative solutions for our environment. So we operate across the water, energy, waste and transport sectors, which puts us in a unique position to provide integrated solutions for industry, commerce, and in supplies of infrastructure to cities generally, so including buildings and domestic properties. Now, as part of the Veolia Group, out here is the Energy Services Division. And you can see from these key figures, which I won't go through in detail, that we've got a vast international depth and breadth of experience. And this is actually in the physical operation of energy utilities plants, covering many technologies in many sectors, in different countries, different applications. So in this role, in developing and operating integrated energy solutions, offers us a unique knowledge bank of how technologies work in practice when you actually operate them, in terms of the cost, efficiency, reliability, maintainability, and operability. You need to get all those things right to actually make the financial returns of any technology to be implemented. So what's energy efficiency from the Dalkia perspective? This is a flowchart showing the energy supply chain for essentially for a particular site. Could be for a city, could be for an aggregation of industrial units. And on the right-hand side here you see the upstream energy procurement, effectively, where it comes, where do you get the raw energy from, be it gas, power, oil, coal, biomass. Key thing for us in Dalkia's core strength is in the conversion of that raw utility into usable energy. So converting gas into heat or gas into power that's for use by our customers. So the second phase there is the actual conversion, and key skills there: operations, maintenance, major upkeep of the plant. How long is the plant going to, how long will it last? What's the life cycle cost of running a piece of equipment? How can you extend the life of a piece of equipment by good operating practice, good maintenance? Moves into distribution. How do you actually deliver that heat then to the point of use? And then the final part on the right-hand side is how is that energy actually used? And how efficiently is it actually used to actually deliver whatever it is that the particular customer's requirement is, be it simply space heating, be it process heat, be it provision of power to drive his industrial process or his IT infrastructure. Now, efficiencies can be gained at any part through that supply chain, and you can work on small projects at each level through that chain. But to get the maximum out of it, they need to be integrated. There's no point doing something up one part of the chain that messes up the strategy of how you're operating the whole of that chain. Across the top of there is the embedded intelligence. Now, embedded intelligence here is talking about the provision of data and how you manage that. And here we've got a chart, technology chart, of how do you get hold of information with which to manage your whole supply chain. It starts at the top there, sensors, raw data, is it a temperature, it's a pressure, it's a flow rate, what's actually happening in the depths of a building or an industrial process. Sensors need to be good quality, you need to be able to rely on them. Not always the case, you get false readings, so good technology is required there and maintenance of that technology. That raw data then needs to be collected through a system, needs to be able to manage it, how accurate is the reading, how often you get it, transmitted through to a then managing software, supervisory software, to allow you to make overall control decisions. Now, a lot of this can be automated, and obviously over the last 10, 20 years there's been big strides made in building management systems, process management systems. So we reached the bottom there is, at the end of the day, you need somebody to manage that system. Putting a system in, they will not manage themselves. They need to interact with the day-to-day operation of the site, pieces of plant that fail, pieces of plant that are operating outside their optimum efficiency, and are not delivering for the overall benefit of the cycle. So in terms of energy efficiency on a global basis, what do I see as opportunities? Well, two main areas at the top there we've got are industrial energy efficiency, whereby there is still huge amounts of energy to be saved. And also then in smart infrastructures and resource management for cities and buildings. I think we'll hear a bit more about that later today. Embedded intelligence, again, you can't manage them if you don't know what's going on, as just described. I think there's a good opportunity for improving how these systems are utilised. The key thing there, I think, is that unless you manage that system, that embedded intelligence, you will not actually glean the benefits. Next point I've got here is arbitrage. Now, in terms of aggregating loads together, too often in the past we've looked at individual uses of energy, individual sites. Putting together larger aggregations of loads allow you to benefit from economies of scale using essentially centralised plants in things like district heating schemes, which allow the use of things such as combined heat and power on a larger scale than you could on the smaller end at the point of use, or the use of renewable energies, the use of different fuel mixes, and therefore allows arbitrage between different fuel sources. So you're not just using the cost of power or the cost of gas, and you're stuck with whatever the market gives you. If you've got the opportunity to switch to a different fuel, so you can arbitrage in terms of power generation if we're running combined heat and power plants, taking advantage of the volatility of the market effectively. Power prices are high, you generate more power on site. Power prices are low, you don't. I think I've already really covered aggregation there. It's bringing together individual households, manufacturers, industrial buildings, again to put a larger demand, a larger load profile with which to manage against the overall system supply at the boundary of a site to the industrially supplied by the energy utility, raw gas, power. And that leads on to the potential for demand response and load management. Now that can be done, and is currently we have some experience of this on individual site basis, and there's the opportunity now through the STORE type program in the UK to manage electricity demand on a half hourly basis. And this, I think, will need to extend with the growth of renewable power generation in the electricity supply mix and potentially higher nuclear capacity. The need to balance electricity supply and demand will grow. And I think there's a lot of opportunities for this. I think one thing I would say is that the systems required and the amount of data that's required and the decision-making capabilities of that system are something that is in its infancy. I think there's some work and pilot projects that we've been involved with that show that this is going to show some benefits. But I think the growth of that market going forward is not going to be straightforward, particularly with regulatory concerns and restrictions that may apply. So I think that's something that I think really looking forward to listen to a bit more in the later presentation. In terms of risks, again, I think as I already mentioned, technology on its own won't solve problems. It won't solve the whole solution. It needs to be in the context of an overall management framework and strategy of how to progress, particularly with the legal framework that we've got. The stop-go type approach, changes in legislation and incentives, changes to emissions criteria that are required over time. The legislative risk of investing in new technology is quite high. And we can get some foreseeable long-term stability in this area. It will go a long way to promote further investment and the take-up of good energy efficiency technologies. So that's something that government needs to work on. You can't underestimate